Hello, my name is Jennifer and I am an acoustic graduate consultant for AECOM. Day to day I try and solve noise problems and I wondered, could noise light my house? I started by looking at the theory. If sound is an energy and noise energy is a waste, meaning that it is annoying, unwanted and loud, could I convert this energy into electricity? Therefore, could I use noise to light my house? Then I looked into the engineering of how does this work and came across something called AEH, or acoustic energy harvesting, and this is split into 3 steps. First, we need noise. The important thing here is that noise or sound is a pressure wave. The second thing we need to do is convert the energy, so we use this pressure wave to vibrate a component. This converts the energy into kinetic energy, which is far more useful than a pressure change. The third thing to do is to generate electricity, and kinetic energy is easily converted through 3 different methods, which we're going to look at next. The first method I looked at was piezoelectric, and this is a fancy way of saying creating electrical potential or current through mechanical stress, which is essentially bending a piezoelectric material plate. You can see that I have a sandwich of materials. I have those in blue that conduct electricity and my piezoelectric crystal in the middle. When my sound wave interacts with this sandwich, it starts to bend and we can see we have a positive and negative potential as we do so. The second method I looked at was electromagnetic, and you might be more familiar with this. Here we have an electric current that's produced from a changing magnetic field, so it could be that our sound wave is moving the magnet or the coil. And in my image here you can see my magnet and my coil, and the sound wave is vibrating the coil, so it's moving through the magnet, creating this electric current. The final method I looked at is triboelectric, and this is another fancy term for the electrical potential or current produced from the friction of 2 dissimilar materials. So you can see my dissimilar materials are in green and red, and my electric conducting materials in blue. What we do is have one side fixed, one side free, so that when our sound wave comes through, we create this frictional interaction, and this generates our electricity from the pressure change of sound. If we look close up at a real world noise barrier, we can see these different units and we have the sound wave coming in. So focus on just one movement and move the magnetic coil out of the way. We can see that in blue we have our sound wave coming in green we have our sound wave reflecting black, and it is this cycle of pressure in and out that creates a vibration of our magnet, creating the electricity that powers this light bulb. The next thing I thought about was, where could we get this noise, this energy source? This would need to be loud, constant and noisy. So I'll let you think about some ideas. What I came up with was next to a road and also next to a railway, because these are constant, loud noises. I was really excited about this technology, but my final thought was, will this work in the world today? And the short answer was no. The energy produced is too small. Far from being able to light a light bulb, noise as an energy source can only light something like an LED or a microsensor. Therefore, for this to be possible in the real world or viable, what we need to improve is better microelectric technology that requires much less energy than current technology in order for us to light our homes with noise. Well, thank you all very much for listening. I hope you've learnt something and had some fun. And maybe in the future I'll be seeing some of your videos explaining some more interesting engineering and science concepts, and maybe even some more in acoustics.